Welcome to our training module on cooling fan repair. During the next few hours, we will show you how to take a typical fan apart, repair it, reassemble it, and make the necessary adjustments for proper operation. First, however, we will familiarize you with cooling fans, explain how they are used, and relate the nomenclature of the basic parts, as well as the terminology common to these pieces of equipment. This is a common cooling fan now in wide use at many plants across the country. As you can see, it is considerably larger than most fans that you may have come in contact with. In fact, this particular cooling fan is 20 feet in diameter. There are two basic applications of a cooling fan which are most common. They are cooling tower fans and air fin cooler fans. This is a cooling tower. Water is introduced near the top of the tower, then splashes down through the tower from one level to another until it reaches the bottom. While this is happening, a cooling fan on the top of the tower pulls cool air in through the louvers on the sides of the tower and blows it out through the top. As you can see, the air is pulled through the water, which results in the cooling process. That's basically how a cooling tower works. However, our primary interest is in the fan, shown here. The second basic application of a cooling fan is seen here on this air fin cooler. This apparatus is practically identical in operation to a radiator on your automobile. The liquid to be cooled is pumped through tubes being pointed out here. Metal fins connect to the tubes, dissipating the heat from the metal tubes. In turn, the fins are cooled by the air blown across them by the cooling fan, being pointed out. As you can see for yourself, both units are used for cooling a liquid, and both units use a different principle. However, both the cooling tower and the air fin cooler require the use of a cooling fan. Although there are minor differences between the two fans, they are basically very similar. This fan is similar to those we have just shown you. We'll use it throughout the remainder of this course. Now we'll point out each of the parts of the cooling fan and tell you the nomenclature for it. To begin with, the entire fan assembly will be mounted on a drive shaft, as shown here. This particular drive shaft is the low-speed shaft of a gear reducer. However, in other uses, there may simply be pulleys on a shaft, as shown on this air fin cooler fan. The entire fan is called the fan assembly. The assembly includes all of the parts that make up the fan. The center of the fan is called, quite appropriately, the fan hub. The hub is actually a short, solid sleeve, with two hub plates mounted on it, one on the top, the other on the bottom. The two hub plates are secured to the hub with these cap screws, now being pointed out. The hub itself is secured to the drive shaft through this split tapered bushing. The bushing is tightened down with the cap screws on top, clamping the bushing around the drive shaft and forcing it into the tapered hub. You'll understand it better when we take it apart during the next segment. These are quite obviously the blades. There are 6 of them on this particular cooling fan. The shank of each blade is clamped tightly in retention sockets, shown here. Each retention socket is made up of 2 halves, which are fitted around the shank of the blade, and then bolted securely between the 2 hub plates. You must also be familiar with the terminology used when referring to parts of the blades in a cooling fan. These are the terms you will be concerned with: leading edge, trailing edge, blade tip, and shank. The leading edge of a fan blade is the front edge, the edge that cuts through the air. For instance, this is the leading edge on this blade. Of course, the opposite edge of the blade is the trailing edge. Here's another method of determining leading and trailing edges of a fan blade. Look closely at the end of this fan blade. As you can see, it is shaped like an upside-down airplane wing. The blunt, or rounded edge of the blade is the leading edge. The workman is pointing out the edge we're referring to. The sharp edge of the blade, as shown here, is the trailing edge. Remember, as we said, the blade is very similar to an airplane wing. By using this method, you should have no difficulty remembering that the blunt edge is the leading edge, and that the tapered sharp edge is the trailing edge. As for the blade tip, the term is self-explanatory. The blade tip is simply the end of the blade. The final term used in referring to a fan blade is shank, which we mentioned before. The shank is this part of the blade, which is clamped in the retention socket, holding the blade in place. There are also a few other terms used in reference to cooling fans, with which you should become familiar. One of them is fan diameter. This term is also self-explanatory. Most manufacturers of industrial fans design the blades so that the diameter of the fan will be fixed. This differs somewhat from older fans, which were constructed so that the blades could be moved in or out, changing the diameter of the fan. This proved to be troublesome in many cases, since it is extremely important that the radius of each blade be exactly the same as the remaining blades. If they are not equal, the blades will be out of balance and will produce vibration, which can be very destructive. Another term which is considered very important is rotation. In other words, the direction the fan rotates, clockwise or counterclockwise. It's very easy to find out by facing the fan from the air outlet or downwind side. If the fan is not moving, the downwind side is the same side of the fan as the flat side of the fan blades. Let's use this fan as an example. As you can see, the flat side of the blades are on the top. Therefore, this is the outlet or downwind side. Viewing the fan from the top, we next locate the leading edge of the blade, being pointed out by the workman. This means that the fan blades turn in this direction, which is clockwise. That's all there is to determining the direction of rotation. Our next term is pitch. You will learn to adjust the pitch of the blades later in this training module. By pitch, we are referring to the angle created by the blade and the plane of rotation of the blades. This graphic illustration shows what we mean. The blades rotate along the dotted line shown, which is called the plane of rotation. However, as you can see, the blades are set or pitched at an angle to this line. This angle is called the pitch of the blade. It is specified by the manufacturer and is considered an extremely important adjustment. Too much pitch moves lots of air, but overloads the driver. Too little pitch takes the load off the driver, but it reduces the flow of air through the fan. Here's something else to remember. All of the blades on a fan should be set at the same pitch. If they are not, an aerodynamic imbalance will result, and the fan will vibrate until it destroys itself. We mentioned the plane of rotation of the fan blades just a moment ago. We said that the blades rotate along an imaginary line, which is called the plane of rotation. It's also very important that all of the blades track along the same plane. As the fan revolves, each of the blades traces an invisible path through the air. All of these paths must be very close to each other. The tolerance will usually be specified by the manufacturer. For instance, if the 6 blades on this fan create tracking patterns like this, it would be considered very undesirable. Again, blades that are not tracking result in imbalance, which causes other problems. The only remaining term we want to pass on is tip clearance. Tip clearance is simply the distance between the tip of each blade and the shroud in which the fan is mounted. If there is no tip clearance, the tips of the blades will hit the walls of the shroud and cause damage. It's as simple as that.